To understand the interconnections between bits, bytes, and bitmaps, please open the tower bitmap sample file. Let's zoom in to the clock face on the tower. Use the zoom tool and make sure scrubby zoom is selected here on the options bar. Position the cursor over the clock face and drag to the right. As you zoom in, there will come a point where the illusion starts to break down and you can no longer perceive which pixels represent the clock and which pixels represent the tower that it's mounted on. And I bring you in here all the way into the pixel level to reveal what a bitmap really is. And that is, it's a mapping of the pixels directly to memory. In this most simplest of cases, we have pixels that are either black or white, no shades of gray. And so the white pixels are ones and the black pixels are zeros. There are 8 bits in a byte. And so down here you can see that this particular image takes a little less than 4 million bytes to represent it. So if you multiply that by 8, it's around 32 million bits. As I zoom out here by dragging to the left, there will come a point where I start to perceive this as a clock. But now that you know the illusion is made of black and white pixels, you can appreciate the difficulty that we have when trying to manipulate a sea of pixels. And that comes usually in selecting something and creating a boundary between what you perceive as the building and what you perceive as the clock. And so this is really an art in terms of making precise selections. If we try to select within the bitmap, you'll see that we cannot. The quick selection tool doesn't work because the bitmap is actually so primitive that it doesn't even support layers. Let's go up to the image menu under mode and change this from bitmap to grayscale and accept the default size ratio of 1. Nothing changes visually, but we now have the ability to use layers, and we can use the quick selection tool as well. I'll make a quick selection by dragging around here, and you can see the challenge that we have here. There are no hard edges that define this as a clock. It's very rough and difficult to select. And this is just part of the fundamental nature of dealing with pixels. This is also known as raster data. There's another type of information that Photoshop supports, and that's called vector information. And an example of a vector tool is down here. I'll use the ellipse tool and change this to shape if it's not already, and go ahead and draw a circle. So the circle, or ellipse, has very crisp edges, and it's defined mathematically as this object. In fact, selecting it is trivial. As soon as you select this layer, it's selected. There's no question about that. It has certain advantages in being able to manipulate it as a mathematical object rather than a grid of pixels. But it also has limitations. So we're always coming up against these two different fundamental data types in Photoshop. And this is especially true with 3D objects, which we'll get into later. 3D objects are fundamentally vector in nature, but they're texture mapped, and they carry with them this concept of raster data in amongst the vector data. So it's this interplay between these two data types that we will experience in Photoshop.